My name is Planan Sikopo. The subject is physical science. We have the topic current, which is going to be our main focus. So what we are going to do is to look at the objectives for today's lesson. Our first objective is that at the end of the lesson, a learner should be able to state that current is related to the flow of the charge. The second objective is that a learner must show understanding that a current is a rate of flow of charge, and recall and use the equation I equals to Q divided by T. And then our last objective, at the end of this lesson, a learner should be able to state that the correct way to connect an ammeter. So these are our objectives, and then from there we are going to proceed with the lesson. In today's lesson, we are going to focus on the current. So what I'm going to do first is to explain the concept of current within electrical circuits. I'll draw a simple circuit, and then I'll indicate how the current is going to be flowing within the circuit, and also to explain the rationale as to why current provides us with a very good flow in any electrical circuit. What is provided, what you see, represents a circuit diagram. So this circuit diagram represents a series circuit. Therefore, when we are talking about the current, the flow of the current, we have two polarities. We have the positive and the negative. The longer one, we refer to it as the positive polarity. The shorter one, we refer to it as the negative polarity. Therefore, you will find that if we have to indicate the positive and the negative, the flow of the current, the electric current, is going to be from positive to negative. And this type of flow, we refer to it as the conventional current. And then we also have another current that can flow from negative to positive, which is referred to as the electron current. So the difference between these two types of currents is that traditionally, if I have to give a bit of a history on how these two currents were brought into context, the discovery, way back, of course, in the 17th century, when discoveries were made on how the electric charge is flowing, they realized that from positive to negative, the assumption was that from positive to negative, this is how the current is supposed to flow. But later on, it was discovered that it's not actually true, in the sense that if we look at the atom, the composition of the atom, one would realize that if we were to draw an atom, the central part will have the protons and the neutrons. Therefore, the proton is having a positive charge. The neutron is having no charge. Whereas outside the nucleus, which is regarded as the central part of the atom, we have electrons. So these electrons, they are having a negative charge. And this is where the misconception was brought in, so that clarity must be given. Therefore, if we look at the atom, what is flowing is regarded as the electrons. So electrons are the ones that are revolving within the orbits. Hence, in this case, they came to realize that it is not correct, scientifically proven, it's not correct to say electrons are stagnant, or in other words, are rigid, as it was assumed earlier. So that's why they came to conclude that when one is looking at an electrical circuit, you must realize that when the current is flowing from positive to negative, we call it what? Conventional current. And when the current is flowing from negative to positive, we call it electron current. So the distinction between those two currents is such that they are all relevant in today's technology. We still have that understanding. It's only that electron current compared to the conventional current is regarded as smaller in terms of size or magnitude. Therefore, what we can conclude out of this scenario is that we have two types of currents. The conventional current, which must flow from positive to negative. And then we also have the electron current. So these are two types of currents that we are talking about. Therefore, a very simple relation is that the two types of currents exist. However, when we talk of the electron current, we usually use it in small devices like semiconductors. Any semiconductor devices, if we talk of a diode, for example, if we talk of a diode of course would allow current to flow in one direction. Throughout, it can be positive, from positive to negative. However, this diode is such that it will have a forward biasing or a reverse biasing, which in simple terms translates to say, when you are having a diode, you can only have one current that will flow from one direction to another direction. But this current will be classified as electron current because in terms of size, it is regarded as small. The conventional current, as I have indicated earlier, that it is this current that will flow from positive to negative. And then what matters is the source, because someone might ask a question. Having this cell, which is regarded as a battery, in this case if I have two or more, it will imply that for current to flow, we have what we call electric charge. So a continuous amount of electric charge flowing is regarded as current. In simple language, this is how people would interpret it. When you have a continuous amount of charge which is flowing within a circuit, it is regarded as current. Therefore, conventional current, once again, positive to negative. Electron current from negative to positive, but they are all classified as relevant currents respectively if we look at them in a broader perspective. So in the meantime, I quickly want to emphasize one thing again in this specific lesson. We are having a conductor in this circuit. So from the positive polarity, which is the longer side, the longer one, to the negative, the conductor is the wire which is connecting. If we were to put an ammeter in this circuit, what will happen is that we can establish the amount of current which is flowing. And an ammeter must be connected in such a way that it must be in series. So if I connect an ammeter, all right, having drawn an ammeter's position within the circuit, we can see that if we want to measure the amount of current which is regarded as the the amount of electric charge which is continuously flowing, the ammeter is the electrical device which will allow us to establish how much current is available within the circuit. Hence, the purpose of an ammeter is to measure the amount of current which is available within the circuit. The other conclusion that we can make out of it, when an ammeter is connected in a circuit, it has to be connected in series. Otherwise, if it was connected in parallel, it means you damage the instrument. We can look at another concept. We earlier specified that we have two types of current that exist in this specific circuit, the conventional and the electron current. These two types of current will always exist in any circuit, as long as there's a cell or as long as there's a battery. So let us quickly make a conclusion, the final conclusion based on this topic. In our objective, we specified that at the end of the lesson, a learner must be able to state that current is related to the flow of the charge. So therefore, the charge in this case would move from positive to negative. So a charge will always be there, as long as you are having a source which is regarded as the battery or the cell. So that source is the one which is going to provide the amount of electrons that will be continuously moving, which is regarded as electric charge, throughout the circuit. Once that is provided, we have what we call electrical current. So a child at the end of the lesson must be in a position to know that the charge would flow from positive to negative. Equally, the charge can also flow from negative to positive. So the only disparity is that we need to make a difference between the two types of currents that exist, conventional and electron current. And then in our objectives, we also spoke so much about the flow of the electric charge, which is quite true that in any electrical circuit, a charge has to be available for what we call current to flow. So they go interchangeably to say the amount of current which is flowing continuously provides us with what we call the charge within that specified in a circuit. Hence, we can also look at the equation that combines the amount of charge which is present within a circuit, including the time. So we are going to write the equation that connects current, the charge, and the amount of time which is present whenever the charge is flowing within the circuit. So this is provided by I, which would equate to the charge Q divided by T. So the equation that I've just now written is the relationship between the current, which is given as I, Q, which is regarded as the amount of charge which is flowing, T, and the time. Because in any specified situation, time is quite paramount in a sense that you need to measure how much charge is flowing within a specified duration. So therefore, that formula connects the charge and the amount of time which is going to be provided within that circuit. So some people prefer to write I, they'll specify this to be the current. And then the Q, this will be the charge. And then the last one, T, represents the time. So therefore, here we have already indicated what those variables represent, I, Q, and T. All right, what we are going to do is to perform a simple calculation based on the relationship between current, charge, and the amount of time provided within a circuit. Having this equation I, which equals to Q divided by T. So suppose you were talking of a conductor. A conductor is a piece of wire. I can draw a piece of wire, then say this wire this is our conductor. If this conductor is connected within a circuit, so by connecting in a circuit, we are saying if this is a piece of conductor, it could be copper, any other conductor that you can connect in a circuit. The assumption is that if this has a charge of say 200 coulombs. Some people prefer to write just 200 with a capital C, because the capital C is the SI unit for coulombs. So therefore, if the time at which the amount of charge which is flowing in the circuit is at, say, time, let us say the time is at 10. Say minutes, we are required to convert the time into seconds, of which if I have 1 minute, which equals to 60 seconds, Therefore, if I have 10 minutes will give us 60 multiplied by 10. So therefore, these 10 minutes will convert to 600 seconds. So basically, I'll just multiply 10 by 60 to give us 600 seconds. So this 600 seconds is the time which is going to be required to be substituted into the T in the main formula of I equals to Q divided by T. So therefore, if I substitute 200 coulombs, which is provided to be the charge, over 600 seconds. So this will give us 1/3 amperes. So this 1/3 amperes is the equivalence in decimal to 0.33, which is going to repeat in any case amperes once again. So this is the amount of current which is required for this specific conductor. Alright, the summary to this lesson is that we of course now looked at the flow of the current. We specified in our initial explanations that when one looks at this circuit, we have what we call conventional current, which is the current that must flow from positive to negative. And then we have the electron current, which must flow from negative to positive. We also looked at the position of the ammeter. Where exactly can we position the ammeter within a given circuit? We agreed earlier that an ammeter must be connected in series. And then I also went on to explain the idea of the electric charge. Where was the notion of electron current and conventional current came from? Those two concepts. I spoke about the atom, where I said when one looks at an atom, of course, we have the positive and the negative, and the neutrons that forms the central part of the atom, which is regarded as the nucleus. And then outside the nucleus, we have what we call the electrons. And then we also looked at the simple scenario where I gave an equation of the relationship between current, charge, and time. So we need to do a conversion to convert the time from minutes to seconds. Because if I have a coulomb over time in minutes, only then that's when I can talk about the amount of current, which is regarded as the amperes. So this is where I went on to give 200 charge, the amount of charge which is available in that circuit. So in summary, we have reached the end of this lesson. This concludes the lesson for today. Until next time,